Let's get started. Please confirm if my screen is visible. Hope my voice is audible and my screen is visible. Okay, Shashwant. Okay, yesterday we were seeing about character and the Unicode. So let me write it like character data type. So character data type. So whenever you talk about a data type, you talk about the 4 points. You talk about the size. The size of the character data byte is ranging from 0 to 65,535. So the minimum value is going to be 0, the maximum value is at 65,535. And we know that this character data type is a unsigned data type. It means it is not going to support the negative values. So unsigned data type. The third valid point is the size of the character data type is 2 bytes. 2 bytes, which is also equivalent to 16 bits. So when you want to represent this in the memory, 16 bits of registry will be created. The fourth point is you can use this data type to store a single letter, or I can say that you can store any letter from any language. It can be a special symbol, it can be from a different language. So this is going to support majority of the world's languages, not all the languages, majority of the world's languages, right? So if you want to represent any character by using char data type, you will have to represent that in a single quotes, right? For example, if you want to represent the alphabet A, this is how I represent. Only one letter is possible. This is valid, and this is not valid. At most one letter is possible, and this is also not valid. We will discuss about these cases going forward. These are the 4 things that you should remember when you talk about the character data type. As simple as that. So today we will try to understand about the conversion of a decimal number to the hexadecimal number, right? After that we will try to do some post-mortem on this character data type. Yesterday itself we have covered a lot of things on top of character data type, right? But there was a little confusion, right? Today those confusions will be clear, right? And one more point I would like to add: internally this character data type has adopted the Unicode system, and we have discussed about this Unicode system yesterday. Internally, character data type in Java has adopted the Unicode system to represent the letters from different languages. Not only letters, you can also represent symbols, you can also represent spaces, right? Any single character within single quotes. This point should be clear now, right? So now the question is, if we ever had to represent a character, we are going to represent a character with a single quotes, and we need to put a valid character, right? And you must be wondering why we are why the range is between 0 to 65,535. Right? I have answered this question yesterday. Today we will try to do some deep digging on this part, especially on this range, right? Before proceeding with this, let us understand about the hexadecimal number system, right? So we want to understand how the conversion happens. I know that you know these things already, but let me try to put this in a simple way. So decimal to hexadecimal conversion. For example, let us say that I have a number 23 2949. So this is a decimal number. So decimal number is always represented with base 10. I want to convert this number to the hexadecimal number. So hexadecimal number is going to follow the base 16 methodology. I want to convert this 2649 into an hexadecimal number. Right? We know how to do the conversion from decimal number to binary number. We know how to do that. Today we will understand how to perform the conversion from decimal to hexadecimal. Why we are trying to understand this? Because understanding this will help us to understand about the Unicode system. Unicode is represented in the form of hexadecimal number. That's the reason why we are understanding about this base 16 numerical system. Right? For that, I have already created a table. So this is table. Let me bring this table here. Right? So these are the numbers. These are the decimal representation. These are the decimal numbers. 0, 1, 2, 3, 4, 5, 6, 7. These are the decimal numbers. If I want to represent these numbers, if I want to convert these numbers to hexadecimal number, so the conversion is going to be as follows. So 0 in hexadecimal as well, it is going to be 0, and 1 is going to be 1, 2 is going to be 2, 3 is also going to be 3, 4, and there we go, 5, 6, 7, 8, 9, and from 9, if you see, 10 is not going to be 10 here. 10 is going to be A. 10 is going to be A. And the numerical decimal number is going to be B, C, D, E, F. Right? If you count if you count everything from 0 to 15, it is nothing but there are 16 numbers. Right? There are 16 spaces. Right? So that's why I have taken the 16 blocks. So each and every block is representing a single digit, and this is how the conversion is going to be with the hexadecimal number. Okay. So let us keep this table aside. Now our my intention is to convert 6949 to the hexadecimal number. To achieve this, I will do a simple division. I keep dividing this number with 16 until I get the remainder less than 16. Right? So decimal number. This is a decimal number that I have. What is a decimal number that I have? 2949. Decimal number. My intention is to convert this decimal number to the hexadecimal number. The procedure is very simple and straightforward. Keep dividing this number with 16. Why 16? Because 16 is the base for the hexadecimal number. That's why we are going to divide it. Keep dividing it by 16. If I do this, 29 means 16 ones, and you get remainder 13. 13 means 134, and it is going to be 8 times, and you get remainder like 69. 69 means 4. So, and the remainder is going to be 5. I am keeping the remainder aside. Again, divide it by 16. Right, 16 ones, and 2 will be carried forward, and again 16 ones, and the remainder is going to be what? Right. If you see the value, I have. So these are the reminders. So remainder should be taken from bottom to top. Right. So here I have 11. Right. What is the equivalent value of 11 for in hexadecimal? B. Right. So I will take it as B. And 8. Equivalent value for 8 is 8 itself. So 8, 5. Right. So this is the value. B85 is the actual value. Actual hexadecimal value for the number 294. 8. So decimal number has been converted to hexadecimal number. Right? If I want to do it in the reverse order, like reverse order in the sense converting the hexadecimal to the to the decimal equivalent. Right? So This is how it can be converted. Let me take the least significant number 5, the first position number, like 5 into 16 times of 0 equal to 8 into 16 times of 1 equal to b into 16 times of, so 5 into 16 times of 1 is going to be what? 5 itself, because 16 to the power of 0 is 1, so 5 into 1 is 5, right? And this is going to give us a value like 16 1 16 8 128, right? So b is, again, see, if when I say b, the equivalent decimal number for b is what? 11, isn't it? So 11 into 16 square, right? 16 square we get 2816 into 11, right? 256. 256 into 11. 256 and 256. What we get? 6, 11, 8, 2816. 6, 11, 8, 2816. 2816. You do the calculation and we get what? This is going to give us 9 and 4, and this is going to give us 9 and 2. 2949. So we are getting back the equivalent decimal number. I hope you have understood the conversion between from decimal number to binary, sorry, decimal number to hexadecimal, and the vice versa, hexadecimal to decimal. Let us keep this knowledge aside, right? Yesterday I was telling you, if you remember, right? So a character, so let me take a notepad. When I say character, this is char is the data type. So with this char data type, if I want to assign any value, I will be needing an identifier. So in this case, my identifier is letter. So this char data type, you can assign values in 3 forms. What means a direct character I can assign. Firstly, a direct character I can assign. Secondly, I can assign a number, letter, right? 65. Thirdly, I can also assign a Unicode value. So again, if you talk about Unicode value, the Unicode value should be preceded with what? Appended with \u and followed by an hexadecimal number. Any hexadecimal number we can take. Something like 0085 in single quotes. Right? Literally, this character data type is going to accept values in the form of a single letter within single quotes, or let me use or a number. And when you are assigning a number, it will check for the range. It will check whether the number is between 0 to 65,535. Accepted. Right? Thirdly, it will we are allowed to use the Unicode as well. This is how the Unicode can be recognized. These are the 3 ways that you can use to assign a value to the character data type. Right? So internally, we have also discussed about the internal things externally. Right? So if I do this, let us assume this as the first case. First case. Character letter equal to, if I do this, internally, this A will be what? Firstly, what happens? Firstly, the compiler will try to convert this A into the certain Unicode. This A will be converted to the relevant Unicode. Right? Firstly, the character A. The character A will be converted into the equivalent Unicode. Unicode that is reserved for this letter. Right? So see, Unicode system says that for each and every character, whether either it can be English alphabets or it can be Tamil letters, it can be Telugu letters, right? These numbers are reserved. For A, there is a specific Unicode. It is reserved. It is reserved only for A. If you take the Unicode chart, internally there is a kind of chart, Unicode chart, right? So the Unicode chart has these, some values or some data. So each and every Unicode is going to have or is going to represent a specific letter. It is reserved for the specific letter. Let us understand this is a Unicode chart. Right? So inside the Unicode chart, the Unicode is usually will be like /U. It will start from 0000. For 0000, there will be a specific letter assigned to this particular Unicode, and for 0001, there will be a specific letter. 0001. Likewise, for each and every Unicode, there will be a specific letter reserved for that. Allotted for that letter. This Unicode has a specific letter allotted to this. To take U00C as a specific letter as has been allotted to this. Right? So for A, let us find the Unicode for it. 0. Okay, let us take this example. Instead of capital A, let us take small a. Right? The Unicode for small a is this. Means internally the Unicode system, there is a chart. The chart says if you use U0061, right, the small letter a is reserved for this, assigned to this particular Unicode. As simple as that. Right? Small letter a is assigned to this particular Unicode. Right? So character letter a, firstly the character a will be converted to the equal Unicode that is reserved for this particular letter, and next the Unicode will be converted to the equivalent. The Unicode will be converted to the decimal value, and the decimal value will be converted to the binary number to be stored inside the memory registry. As simple as that. Registry. For example, let us take a small sample program. Let us take that I have a class here. I have class test. Inside the class test, I have what? I have a main method. Okay. Static void name string array aux. Public static void means string array aux. So inside this, I have only one statement. The statement says character letter equal to a. Right? When I do compilation and when I do execution, right, we don't see anything in the console. The console is going to be empty, but the compilation is going to do so many things inside the memory. So that understanding is required. Whatever is happening behind the scenes, I am giving you that knowledge. Right? When you try to run this, you are going to see nothing in the console. Console is going to be empty. Okay, console is going to empty, but when you do the compilation internally, there are so many changes that is happening behind the scenes. That knowledge we are going to, that knowledge we are trying to understand, right? So let me take this to the paint screen, right? So this is my program. So this is my program, and so I need to save this program with what? Test.java. Because this is a source code. We know this already. Every source code, this is how the source code needs to be saved with .java extension, and the class name should follow the .java extension. As simple as that, right? And the source code needs a compilation to check for errors. Compilation will do what? It will usually do the syntactical check and semantic checks, whether the program is properly structured or not, as per the Java standards, right? So the compiler is going to take what? It is going to consume this test.java file. After consuming this test.java file, it is going to convert this test.java file into test.class file. The conversion will happen only if the code is error free. You know this already. After this, the JVM comes into picture. JVM, right? The main duty of the JVM is to execute this program, execute this code, right? So when JVM needs to be started, right? To start JVM, after the JVM is activated, this test.class file will be loaded inside the JVM. These are the behind the scenes. This test.class file will be loaded inside the JVM. As soon as this test.class file is loaded, a main thread will be born, or a main thread will be created. This is what we call it as what? The main thread. Main thread will try to get access to the main method. So this is the typical main method, right? And all the instructions inside the main method has to get executed one by one, right? But we have only one instruction. The instruction says a letter is getting assigned to the character data type. So because of this line, a registry will be created inside the memory. So character data type is going to consume 2 bytes of memory, yes or no? So this is 1 byte and this is another byte. So this is a registry that is getting created for the character data type, right? After the registry is created, so the complete registry is like this. So 1 byte is collection of 8 bits. So 1, 2, 3, 4, 5, 6, 7, 8. Let us edit this. So 16 bits will be created. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, 16 bits are created. 2 bytes, 16 bits. Right now, so this part is done. Now the small letter A is getting assigned to the letter. Small letter A is getting assigned to this letter. Now the identification needs to happen inside. Right? So this A cannot be directly stored here. Firstly, what happens? Right, this A needs to get converted to the respective Unicode. What main thread will do? Main thread will identify the Unicode of this particular character, particular letter. In this case, the letter is A. Inside the Java library, it is going to help us. Inside the Java library, there is a file for the Unicode, right? In that Unicode, it will identify the respective Unicode for this letter A. Right, inside the Java library, there will be a file system. In this file system, there will be a subfile called the Unicode file. Like inside this Unicode file, it is going to identify the respective Unicode for this particular character A. We know that for the particular character A, the Unicode is what? U0061. So Unicode will be identified by the main thread. After identifying the Unicode, so this Unicode is in the form of hexadecimal number, isn't it? Right? So this has to get converted into the equivalent decimal number, right? So how do we perform the conversion? So this is the hexadecimal number 0061. So this 0061 has to get converted into the equivalent decimal number. So we know the formula. We just understood how to do the conversion. Right? So 0061. When you say 0061, which is in the form of hexadecimal, right? The equivalent decimal representation is going to be 1 into 16 to the power of 0. Secondly, 6 into 16 to the power of 1. So this is going to give 1. Right? And again 16, 6, 36, 96. 96, 96, so 97. So now the hexadecimal, the Unicode has been converted to the equivalent decimal number, which is what? 97. Right? And again, this 97 needs to be converted to what? The binary number. Why binary number? Because binary numbers are allowed to get stored inside the registry or the memory blocks. Zeros and ones. Right? Shall we do the conversion? 97. Very simple. 97. Keep dividing it by 2. 2 2s, 2 4s, 0. 2 1s, 2 2s, 0. 2 6, 0. 2 3, 0. And 0. So from bottom to top, we are going to write the number. Right? So 1 0 0 0 0 1 1. Right? Let me delete this. And remaining everything is going to be filled with zeros. Since there is no concept of MSB, so unsigned, this is the unsigned data type. So there is no concept of MSB here. So the leftmost bit is going to be 0 itself. Right? If you convert this again, you will say this is how internally the letter A is getting this many conversions internally. Right? You might be wondering, we are giving only one instruction. Right? The load is very simple. We are giving only one instruction. But to execute these instructions, this many sequence of procedures are being followed inside. Right? First one is compiler coming into picture, main thread, right? And main thread has a duty to execute all the instructions inside the main method. But there is only one instruction inside the main method. Right? So to execute this particular instruction, right, the character data type, it is going to identify the equivalent Unicode, and this Unicode is getting converted to decimal, and this decimal is getting converted to what? Equivalent binary number. This is step 1. Right? So after this, what happens? See, now the control. Now this is done. Right? After this, the control will come into the end of the what? It is going to find the exit point of the main method. As soon as it finds the exit point of the main method, this main thread will be destroyed. Right? After destroying the main thread, so there will be nothing to display in the console. Console is nothing but the screen that we usually see after running the code. So nothing is going to get displayed in the console. Let me run this and check the output. So test file, save. Test.java. Test.java. Okay. So let me open my command prompt. Let me change the directory. Java space test.java c space test.java. That is the command for the compilation. Java c space source file name. Okay, so my directory, I did not point the directory. So d cd space java 3. Okay. So this is where I have stored inside this D drive, and the subfolder is Java 3. Inside this subfolder I have saved. I didn't specify that subfolder, that's why we got it. Java C space test. Compilation is successful. Java space test. So output is empty, blank. Output is empty. But we are trying to understand what is exactly happening between these two commands, right? So when I go back here, so I have used these two commands to perform the compilation and to perform the execution. These are the two commands. So while doing these two commands, internally this many things are happening inside the memory, right? This conversion is getting, we are, even though it is not visible, but behind the scenes these things are happening. Why output is empty? Because we haven't used any statement to display the output in the console. That's why the output is blank, output is empty. Right? Now the second case is, so let me do this, system dot out dot println. I'm trying to what? I'm trying to access this particular variable letter, right? Compilation. I'm just I have just saved this Java C space test start Java space test. Now we are getting A. So this A is not getting displayed directly, guys. Again, what happens? It will go through compilation. It will go through this JVM, and execution means that will be created, and all these things will be performed inside the registry. Right? This is the first line. For the first line, for this particular line, so this many things has happened for this particular line. Right? Now the control comes to the second line. Execution. I mean, accessing the variable. The name of the variable is letter. Right? For the second line, and again, this will get this binary data has to get converted to what? The decimal number, which is 97. And again, this decimal number needs to be converted to the hexadecimal number, which is 0061. Right? This hexadecimal number is also called as the Unicode. So this will be appended. Right? And the reserved word for this particular Unicode will be identified as what? Will be identified as A. And this A will be displayed to the console. When you use the print statement, this is what happening from here to here. So this part is meant for storing the information. Till here storing the information, till here displaying the information to the console. Right? One observation. The first observation is here. Over here, the first observation is here. We have just used what? We have just used the character. Instead of using this character, I also have an option to use the Unicode. Right? Unicode / U. What is the exact Unicode? 0061. If I use this Unicode, if I go back to this, the eye level diagram, this outline, right? From here, the execution will be starting from here. So this part will be skipped, yes or no? So are you able to see three things here? So this is the one thing, direct value, direct letter. This is the second thing, Unicode. This is the number. This says that a developer, you have an option either to assign a letter, or you have an option to assign the Unicode, or you have an option to assign the number. For all the cases, right, the equivalent binary number will be generated and be placed inside the registry. For all the cases, right? But when you try to access, these things are mandatory. Able to understand? Right? So even if I use Unicode, run this code, even if I use direct Unicode, the output will not be affected. That is the proof, sir. You asked me the proof. Output is A itself, but I have just used Unicode. Accepted. Okay, instead of Unicode, let me use what? Let me use the number. What is the decimal equal decimal number? Is 97. I can use this as well. Output is going to be what? Same A. Now we understand why this character data type is allowing the number, Unicode, character, number, Unicode, and character or letter. Right? So previously for the byte data type, for the short data type, or int data type, So we are allowed to only assign the equivalent number that is specified, that is a specific number categorically, it has some range for byte data type, it has some range for short data type, right? For each and every data type, there is some range. So only numbers can be assigned for this integers data type. But when you come to character data type, you can assign a number, or you can assign a Unicode, or you can assign a letter. Making sense? Just type yes in the chat box if you have understood so far. Just want submit. Okay, good. Now we will try to do some problems on this. So before proceeding with the problem, let me take this example. So now I think this my particular explanation has some justification. So the character array will be converted to equal Unicode, that is reserved for this letter, and next the Unicode will be converted to the decimal value. The decimal value will be converted to the binary number to store in the registry. Right? This line is making this many. It has to go through this many functionalities before even getting stored. For us, it is just an assignation, but inside internally, behind the scenes, this many conversions are happening, right? And the second thing, see, second line is accessible. So I can say, while accessing the binary number that was stored in the registry will get converted to the equivalent decimal number, and the decimal number will get converted to the hexadecimal to find the Unicode. And the actual letter that is reserved inside this Unicode for the letter will be displayed to the console. Right? So these many things are happening. Now it is like very clear that why the character is accepting a letter in single quotes and a number or the Unicode, right? So this is the first case. This many things are happening. This is the case 2. Case 1 talks about the allotting the memory. Case 2 is talking about accessing the variable. So this is the explanation. So 1 minute, guys. Hello? My voice is audible? Okay. If this is the exact theory part, right? We will try to sort out, analyze few more things on top of this character data type, right? If I do this, see, I have some Unicode. Three 3077 is a number. Firstly, if I assign a number to the variable letter, which is defined for the character data type, right? This number is going to get converted to what? This number is going to get converted to the equivalent binary number, right? And the value will be stored. But the second line, the line number 10 says that letter is trying to get accessed, right? So the binary number that was already saved will get converted to the decimal number, and decimal number will get converted to the hexadecimal number to find the Unicode. Right? As soon as the Unicode is found, the respective value that was assigned to that Unicode will be displayed. So for this particular letter, for this particular number, is the Telugu letter. This letter is assigned to this particular number, not for this particular number, for that particular Unicode. Right? So let us take one more example. /u 0395. So this is Unicode. Unicode will be converted to decimal. Same thing I am repeating. Tamil letter. Right? All the letters from all the languages, all the major languages from the world can be accessed by using the Unicode. That's the specialty about this character data type. Internally, that's why the character data types has adopted the concept of Unicode system, so that it can represent all the major languages from the world. Right? So now let us do some more thing, few more analysis. So now I am saying letter, instead of taking letter, we will keep it very simple. Character A equal to 97, character B equal to 20. Right? System dot out dot println A plus. Right? Firstly, 97 plus 20. 97 plus 20 is going to be 107, 117, isn't it? It's going to be evaluated to 117 because we are performing the addition, so 117. Right? So firstly, let us print what the 117 says. What is the actual value for the 117? What is the actual letter for the 117? So compilation, execution. So U is a letter assigned for the 117. Not for the 117, this 117 will get converted to Unicode, and for that Unicode, the letter U is assigned to reserved for that Unicode. Right? So 117 is for U. But if I do this, character A equal to 19, character B equal to, let me write it here. 117 is for character. So this will not be compiled because I have commented this. So you don't need to worry about this. 37. I am doing A plus B. Now tell me, if I do A plus B, right? I am doing A plus B. This A is of character data type and this B is of character data type. Right? So 90 plus 37 is going to give me what? 100, 110, 120, 127. Okay, let me take it as 27. So 90 plus 27 is going to give me what? 117. Yes or no? Right? Now what will be printed in the console? I'm using character data type. I'm adding A, B. I'm doing A plus B. Will we get 117 or will we get U? Question is making sense? The answer is going to be 117 or the answer is going to be the equivalent U. U. Samyukta says U. What about others? Ganesh, Chaitanya. Chaitanya says 117. Ganesh, Shashwant. No output. Okay. Ganesh. Okay. So let me do this. Let us run this. We will find who is correct and wrong. Java space testing. The answer is 117. You might be wanting why 117, because 117 is representing the character U. You should be print, the character letter U should be printed, but why 170? If we go back to our previous classes, I was telling you, right? When you do any mathematical operation inside the system.out.println statement, when you do any mathematical operations inside the system.out.println statement, right? So internally, these numbers will be converted to integers. Internally, right? We are performing an addition operation. I already said, when you use the plus operator inside the system.out.println, right? Whatever, if A is meant for any, it can be any data type. It can be character, it can be byte, it can be short, it can be anything, right? In this case, it is character, but still that character value will be converted to integer value and it will be positioned here, right? In this case, 90 is a character value. If I try to access directly this character, no issues. I don't have any issues. I'll be getting the equivalent letter for this character. If I do this, Z is the equivalent letter for the character, for this number 90, right? If I try to access B, independently I'm accessing, right? Let me try to access B. I'm not sure what is the character. It is, a kind of space, this compilation, some character is there. 27 as some character, but this online compiler is not able to recognize that. Some character is there. So independently, if I try to access, the respective characters are getting displayed. But if I try to perform the addition operation by using this two character data type, if I try to do this, if I introduce an operator between these two character data type, right? This character data type will be considered as the internal integer data type. The conversion will be happen only for this particular system.out.println statement, right? So this 90 is of character type. But when you do the addition operation, right? When you introduce the addition operator, right? It is character, but it is going to get converted to int. System is going to consider it as an integer. Likewise, B is what? Character, right? But you have introduced an operator plus, right? So the system.out.println statement is going to consider it as, convert it as int. Int plus int is going to give what? Int. 90 plus 27 is what? Equivalent 170. Making sense? Understood? Output will always be there. See, if you see system.out, whenever you are using system.out.println, right, output will always be displayed. This will ensure that something is getting displayed in the console. Okay. So there are no chances that, in any case, there are no chances that there will be no output. Okay. There are chances that we may get errors. Compile time errors are there and runtime errors are there. But whenever this statement is used, it's high possible that the output will be displayed to the console. But what the exact output that will be displayed is the question. Okay. Right now, now you tell me. Instead of doing this, I am doing this in the other way by using another methodology. I hope you will answer this. With this, we can conclude this character data type. So I am doing C equal to A plus B. Character A equal to 90, character B equal to 27. Character C equal to A plus B. Now I am trying to access the variable C. What is C is defining what? C is a resultant value of A plus B. Means 90 plus 27. Now you tell me, will I get 117 or will I get the equivalent to a letter U, or will I be getting any other thing? Now you tell me. Think and tell me. Think and tell me. Okay, Chaitanya says error. Error. Ganesh is also saying error. Right? Samyukta and Shashwan. Think and tell me. We have discussed these things in the previous classes. Jashwant is straightforward. Don't know, sir. Okay, let us try to execute this. You will find who is correct and who is wrong. I haven't saved this. Let me save this. See, error we are getting. So why error we will discuss. Lossy conversion. You people are right error. So this is the error that is being thrown incorporated as possibly logic. So we have been discussing this for almost 3 to 4 classes, right? So this plus operator will expect integer in both sides, right? So if it is not integer, no problem. The resultant type should be an integer, right? So that is the rule. That is how internally the primitive data types are designed when you start performing addition operation, right? Let me bring this in the paint box. Right. So let us perform the execution. Let us do the tracing. We know a memory registry will be created. 2 bytes of memory registry, and after conversions, the binary number will be stored. Likewise, for the second line, the exact binary number will be stored. And the third line, we are saying A plus B. So A is of character data type and B is of character data type. Right? This plus operator is always going to expect what? Int types on its either sides. Should be integer type or larger than the integer type. Right? So in this case, it is character type, no problem. But the resultant value, the resultant variable, and the data type of the resultant variable should be integer type. Then okay, no problem. But in this case, it is what? It is of character type. That's why we are getting it. So this is how it should be. Right? Now the conclusion is byte plus byte, byte plus short, or vice versa, short plus byte, right? Char plus char, right? The resultant type should always be what? Integer type. Right? And other possible cases are there, right? The other possible cases are what? Byte plus char. You can also try this. Char plus char plus short, right? Integer should be the resultant variable's data type, right? So to avoid this error, right, let me do this. Just instead of char, let me convert to int. Right, now the error will be eliminated. Right. So the conclusion is very simple. The character data type is used to represent all the letters from all the major languages in the world. Internally, it has adopted the Unicode system. Right, and when you want to talk about character data type, talk about the memory, talk about its range, talk about its signature, and talk about its the adopted Unicode system. Right, and we have also discussed about the conversion decimal to hexadecimal and hexadecimal to decimal number. So these conversions are discussed just because to understood about this Unicode conversion. Right, so when you assign a character A, for example, so after compilation while execution, this A will get converted to Unicode, and this Unicode will get converted to the equivalent decimal number. This equivalent decimal number will get converted to what? The binary registry. Right, when you try to access, right, the reverse order will be followed. Right, this binary will be decimal, converted to decimal, and this decimal will be converted to what? Unicode, and the while displaying the data, the reserved word, the reserved letter for this Unicode will be identified and will be displayed to the console. Right, And so these are the cases. These are the interview questions, right? You may expect this kind of interview questions, right? And after that, we have also discussed about. Oh, yeah, that's it. I think we have discussed so much. This is that. And this is what we complete theory about. This is there are three possible ways. The three possible values that you can assign for the character data type. One is the direct letter with single quotes, a number, and the Unicode. Right. This is the case one. So this is the equivalent definition for the case two. This is the equivalent definition. Right. And that's all about this. And one more thing I need to introduce you. So it is not going to take much time. Right. If you want to convert a binary number to the decimal number directly, so these things you should know. Let us say that I have a binary number like 1001013, right? So my intention is I want to convert this binary number to the decimal number directly. Right? For that, what I will do a small changes, very simple change. The change is like I will use the same binary number, right? The same binary number. I will append this, not append. I will just precede some values in front of this binary number. So what value I am going to precede, that is the question. Simply I can attach 0b, 0 small b, or 0 capital B. If I do this, 0 capital B, right? This binary value will be converted into the decimal value directly. So let me save this and run this. One 137. Very simple, isn't it? I have a binary number. I'm converting the binary number. I want to convert this binary number to the equivalent decimal number. So without writing any logic, I'm just adding 0 capital B, or you can also add 0 small b, no problem. You will get the equivalent decimal value. So this has been introduced in Java 1.7, right? This is one of the optimizations, 137. Either you can use small b or capital B. Now you tell me whether this is valid or not valid. Whether the statement is valid or not valid, now you tell me. Not valid, not valid, not valid. That's correct, not valid. Because this will expect, right? Following this these two characters will expect the complete binary number, the full-fledged binary number. This is not going to be a binary number, yes or no? Because it has a numbers that is not part of the binary values. 234 is not part of binary number. So that's why we get what we get error. The error. Illegal sort of expression. Right? Likewise, we have another thing, right? We can also do what? We can also do hexadecimal conversion. Right? Instead of using 0p, I can use 0x. Right? This number is going to get converted to the, this hexadecimal number will get converted to the equivalent binary number. Let us see this conversion is happening or not. Happening, right? So instead of doing these things manually, you can follow this approach, right? To do binary conversion, just add 0x. To do hexadecimal conversion, to do hexadecimal conversion, just add 0x. To do binary conversion, add 0b. But please ensure that you are specifying the right binary number. It can be small b or it can be capital B. For binary to decimal. This is for hexadecimal to Simple. Right? Making sense? That's all about this character data type. And in future, right after completing float and double data types, we are going to see a lot of problems how to convert from one data type to another data type. A typecasting concept of typecasting that will be very very interesting. After that, we will start discussing about the if block and else block and for loops. Then we have to solve a lot of problems on bitwise operators. We have just studied bitwise operators, but to do this problem solving, we need to understand about if block and else block and for loops. That's why I haven't introduced any problems on this bitwise operators. Right? Any doubts you have? If you have any doubts, you can ask me. If you don't have any doubts, we are good to go.